Let's begin with creating the charge, the most crucial part of convergent charging. A charge is the core concept that calculates the monetary amount for a customer's service usage. This is defined within a charge plan, which is a collection of one or more customized charges, e.g., one-time, recurring, or usage-based, that are configured using price and charging plans, tables, and macros. A persistent counter is a numeric variable whose value is permanently stored in the database and is updated during charging and refilling processes. For simplicity, we will not use these concepts to keep our focus on the overall convergent charging process. A charging reference is a placeholder within a charging plan that acts as a stand-in for a real external account. It is used during the design phase when the specific subscriber account is unknown, and it links to the subscriber's actual external account when the contract is created. An internal reference is a technical identifier used to map the result of a charge calculation to a specific account in the system. It is defined in the internal reference dictionary within a charging plan and translates into a specific external account during runtime, enabling the system to charge the correct account internally without using a customer-facing number. Let's create the price plan now. A price plan is a decision tree structure that contains the logic for calculating prices, but not the prices themselves. It is built using simple components that act as building blocks, allowing you to create complex pricing rules for usage-based, recurring, or one-time charges. The price plan is a core part of a charge, and it works alongside the charging plan, which determines which account to debit or credit. Let's add the usage-based plan first. A usage rate is a component of a charge that determines the price for consuming a service, based on specific usage events like data bandwidth, CPU time, or a number of calls. It processes chargeable items usage records, calculates the price using information from tables, and sends the resulting billable item to the billing system for invoicing. A charge must have a usage rate to create an access object in the system, which links a subscriber's account, user ID and the service ID to the usage events. Let's add our chargeable item VREV to this usage-based charge, so it can be used while rating our SIT. Now we can add our range table inducer from comparator option to determine the price based on our plan and consumption. As you can see, we have selected our range table class and range table. Let's map the range property to SIT quantity that will come from SIT as data used by user in that period. Now we map the input plan with service identifier field of SIT. With this information, proper row of range table will be selected and UBP usage-based price will be derived. Now we need to handle below 4 events. If the data usage is very less, say in KBs, then we will charge a fixed amount $5. For this we had used flat function. If the data usage is in range, we will use line function to derive the UBP from range table as our price. If the data usage is in last unbound range, then also we will use the output of range, so we will copy-paste the above linear function. Now if the input plan is not in range table, then also we will charge flat $5. This is all about usage charge. Now we add $10 recurring charge. Recurring charges for every month. Now let's add flat function for $10 as recurring charge. This is all about recurring charge. Now let's add one-time charge. For simplicity we will not add plan-based one-time charge. That adds complexity, and usage-based charge itself as recurring charge and one-time charge are not associated with SIT, so property, service identifier cannot be derived to calculate the amounts. Let's add one-time charge as flat $100. One-time charge should be applied at activation. Now that our charge has all component, let's save it to database. With this, our 5 more steps are completed. We will start with new topic in next session.